Hi, so in today's video, we're going to talk about simplifying integrals using trig substitution. So in trig substitution, the first thing we want to do is identify which of these three expressions are in our denominator. So it is if it's either the square root of a squared minus x squared, the square root of a squared plus x squared, or the square root of x squared minus a squared. Once we do that, we're going to substitute with the corresponding x value that is in this chart, and then we're going to use the identity theorem to simplify our expression. So let's do an example to see how it works. In our example, we have the integral of x cubed divided by 4x squared plus 9 to the 3/2 dx. So the first thing we want to do is we want to rewrite it so that we have a factor of a square root, instead of the power of 3 divided by 2. So the way we're going to write it is we're going to write the integral of x cubed times 4x squared plus 9 to the 1/2, which is our square root, times whatever is remaining. So that's going to be 4x squared plus 9 to the 1, which we don't have to write. So dx. Now, if we look above, all of these factors in front, there's the coefficient in front of the x squared is 1. However, in ours, it's a 4. So we need to also mimic it so that it's a 1. In order to do this, we are going to divide this fraction by 4, rewriting it as the integral of x cubed divided by x squared plus 3 divided by 2 squared to the 1/2 times 4x squared plus 9 dx. So now we've rewritten this factor in terms of x squared plus a squared, where a is 3 divided by 2. So a is equal to 3 divided by 2. Knowing this, we need to identify which of these three it is most similar to, and we can quickly see that it mimics this form of a squared plus x squared. So once we know that, we can assign x to this corresponding value. So x is going to be equal to a tan theta. So let's write that. X is equal to a tan theta. And we just said that a is equal to 3 divided by 2. So we can set x equal to 3 divided by 2 tan theta. This means that dx is equal to 3 divided by 2 secant squared theta. Knowing this, the next thing we want to do in these problems is we want to solve for the square root of 4x plus 9. Doing this step is going to help us down the line and make our life a lot simpler, because it's going to get rid of the most difficult step. So, in solving this, the first thing we want to do is we're going to do 4 times x squared. So we just said x is equal to 3 divided by 2 tan theta. So 3 divided by 2 tan theta squared plus 9. So we can rewrite that as 4 times 9 over 4 tan squared theta plus 9. We can simplify this by crossing out the 4, giving us 9 times tan squared theta plus 9. We can then take out a factor of 9, giving us 9 times tan squared theta plus 1. And at this step, we realize that tan squared theta plus 1 equals to secant squared theta using our identity portion. So we can rewrite this as 9 times secant squared theta. And when we take the square root of that, we get 3 secant theta. So 3 secant theta is equal to the square root of 4x plus 9. Once we get this, we can rewrite the integral. So we can rewrite this integral. So let's rewrite it here at the bottom. So currently the integral is x cubed over 4x squared plus 9 to the 1/2 times 4x squared plus 9 dx. So this can be rewritten as x cubed, where x is 3 over 2 tan theta, 3 over 2 tan theta cubed, divided by the square root of 4x plus 9, which we just said was 3 secant theta times 4x plus 9, which is just this part without the square root. So 9 secant squared theta. 9 secant squared theta times dx, and we said dx was 3 over 2 secant theta. So times 3 over 2 secant squared theta. So now let's try to see what we can cross out. So we can cross out this, and that is it. So let's now rewrite our integral. So we can rewrite it as 3 over 2 cubed would be 27 over 8 tan cubed theta over 3 secant theta, 3 times 9. So 27 secant theta times 3 over 2. So we'll just put this times 3 over 2. So we immediately see that the 27s cancel out, which means that we can take out a factor of 3 over 16. So this integral can be rewritten as 3 over 16 over tan cubed theta over secant theta. So we don't want to leave this integral in tan and secant. We're actually going to rewrite it in terms of cosine and sine. So if we rewrite it, let's get rid of all of this. When we rewrite it, let me use, we can see, so I'll write it up here. So our integral right now is 3 times 16 times tan cube theta over secant theta, d theta. So we actually know that tan is just sine over cosine. So that means tan squared cube theta is just going to be sine cube theta over cosine cube theta divided by secant, which is just 1 over cosine. So 1 over cosine theta d theta. So that means we can cancel out the cosine, leaving us with cosine squared theta, meaning that our integral is going to be sine cube theta over cosine squared theta d theta. So we can rewrite this using our identity theorem. So since we know that sine squared theta plus cosine squared theta equals 1, that means sine squared theta equals 1 minus cosine squared theta. We're going to rewrite this integral as sine theta times 1 minus cosine squared theta divided by cosine squared theta d theta, where 1 minus cosine squared theta is equal to sine squared theta. So once we have that, we're going to use u substitution. So let me get rid of this arrow. We're going to set u equal to cosine theta, which means du is going to equal to negative sine theta d theta, which means that d theta is going to be du over negative sine theta. And when we substitute, let's move this to the side. And when we substitute this, we have an integral of 3 times 16 from the integral of sine theta times 1 minus u squared over u squared times d theta, which is du over negative sine theta. We can cancel out the sine thetas, giving us negative 3 over 16. I move this negative out, times the integral of 1 minus u squared over u squared du. So this is the simplified integral, which is now very easy to solve. Thanks for watching. I hope my video helped you.